Hello friends, this is Matt Domain. Today I am going to discuss about function. I have already discussed function in my very first video, but today I will again discuss this topic. Uh, Now a function. So we usually see, this type of notations: f from a to b. Now the basic question is, what is this f, what is this dot, what is this a, what is this b, and what is this arrow means. I'm going to discuss this topic again because function is a very undertaught topic in your higher secondary. Most of the student qualify in mathematics with very good numbers, but they don't know what is a function, and there are many ways of defining a function, but I'm following a rule which directly starts from the function only. So let me say what is a and b. In the function we have written a and b. See this f from a to b. So now this a and b are sets. Okay, now this a is domain and b is codomain. Okay, now what is domain and codomain? For that, let me draw a diagram. Suppose this is your a and this is your b. Okay, now consider f to be a rule. Rule means we have various rules in our country: traffic rule, this rule, that rule, bribing rule, and all that thing. So in mathematics also we have rules. So function can be defined in many ways using relation, because function is also a kind of relation, but I'm not going to that corner to discuss relation. uh, so we termed function f as a rule. So what is the rule? Means what this rule for? The rule is defined so that there it is a set. Okay, we have these are sets. Okay, these are sets. So this is these two are sets, so they contain elements. Okay, even if they are empty, we have something for that, but first of all consider they have elements, so they have some points. Okay, I hope it is visible. Okay, now what does this rule do to these sets? Now the thing is that, suppose this is a point, so by this rule f, this point is associated or related or connected by connected to a point of b. Now this is x and this is y. Okay, then by rule f, x is connected to y. So in relation, in the term of relation, we usually write x comma y belongs to the set f. Now f is also a set, I will define it. Now x comma y belongs to f. Now the question is, if I have a set capital A, x is a point in it, and if I have another set B containing a point y, and I have a function from a to b, and that function, it takes x to the y it means y is equal to the quantity, because function is of any form. It can give vector, function can give matrices, function can give many more things. Okay, so I'm not saying it is a number. It's always a number is a wrong concept. Basically, if you are a student of mathematics honors in BSc, so function can give only real number is not the case. In higher secondary it is okay, but it is not the case with the function in, you can say, BSc or the graduation. So f of x is a quantity. It could be a matrix, could be a vector, could be a polynomial, could be anything. So f of x is a quantity, and as x is connected to y by the rule f, it means the quantity, the x, you can say the result of x with respect to the rule f is equal to y. Whatever y is, y could be a polynomial, because b could be a set of, you can say, polynomial, you can say matrix, you can say vector, anything. So whatever the set b may be, the x under this rule f is equal to that quantity y. Okay, so this is what this a and b does. So what is this? A is domain and b is codomain, means the function takes a value from the domain and assign it to a, or associate it with a point in b. Okay, now the set from which we consider the points, okay, to be assigned is called domain, and the set of points at which these x are connected is called, or associated, codomain. Okay, so this is domain and codomain. Okay, now come to some interesting things. Now we have seen this part of domain and codomain. Now if you consider again, better you have understood, better to understood these things in the form of diagram. Okay, now suppose this is a function f. Now if the set contains these many points, okay, the domain contains these many points and codomain contain these many points. Now suppose if these points, I have chosen these points, and every one of them is connected to some point of this set, and these 2 points are left out, then this f is not a function. If these 2 points are left out, then this f is not a function. Now for the function f, these 2 must be assigned to some points in set b, better to name them, okay, a and b, some points of b. Now it is to be noted that for f to be a function, every point of the domain must be connected to a point of codomain. Okay, fine. Now if this is a point, suppose this is a point Okay, now this is associated with this point. Let's assume this associated with this point. Now similarly every point is associated with every point of A is associated to some point of B. Now there may be a scenario that two different points of A is connected to same point of B. This thing is allowed in function, okay, but this is not allowed. If the same point is connected to two different points, then this scenario is not allowed in the function. Means for every point of the domain it must connect to a single point of codomain. Two different points of domain can connect, okay, to a single point of codomain, that is fine, but the single point of domain cannot connect to different points of codomain. So this is always welcome. Okay, now the next question that arises from this figure is that, better to name it earlier. Now the important thing is that 2 point can map, or you can say 2 point can be connected to a point of B. Mapped, I have used the word map because sometimes function is also termed as mapping. Okay, so 2 points of A can be connected to a single point of B, but single point of A cannot be connected to two different points of B. So that what we have learned till now. It means if it has a, say this part very clearly, 1 2 3 4 5 points. Okay, it is 5 points, and in here it has 3 points. Watch this part clearly. Now what we do, let this is connected to this one, this is connected to this one, this is connected to this one, these two are left out. So to make the function we make this connection. This is fine, this is no problem, it is very much okay. Okay, this is very much okay. Now this is a function. Okay, it may happen that there are some points in the codomain which are left out, and it is okay, we can left few points in codomain, but you cannot left any point from the domain. Plus two different a single point cannot map to two different point of codomain. So this is okay. Now the important part is not this one, it is already explained in the last slide. So better to change the color. Now all this point maps to these 3 points. So these 3 points, let me separate it with this set, this part. This is called range. This set B can have more than the point of the range, but the range is all those points where the points of the domains are connected. Okay, so this is called range. This is the range. So what is this? These are the parts we have already explained. This is fx. Now y is equal to fx, means whatever point you have, this is equal to fx. So I can see these are nothing but set of this set is nothing but set of f of a. Okay, now how to define f of a? F of a is all those y belongs to B such that y is equal to f of x, and this set is called range. Okay, range of a function. So this is range. We have discussed domain and codomain. So while writing, we write f is a rule. F defines the rule from the initial set, that is domain is A, to the codomain B. This representation doesn't talk about the range of the function. It simply says f is a rule from the domain A to the codomain B. So this line signifies this, or you can say this representation signifies the rule, the codomain, the domain and the codomain. So this is about function, and hopefully you have liked the video. So if you like the video, I will continue this topic because it is already there in the playlist as preliminaries, but we will private those videos because the quality of the video is not that good. So we'll continue making such video in this format so that for better understanding and all that. Okay, thank you, bye.